On the second tab, we are going to conduct a regression analysis to determine if the type of cider, whether it's sweet, semi-dry, or dry, and the production volume can be used to predict the total cost of production. We're going to use an alpha of 0.05, and we're going to have to do binary encoding for the variable cider because it's qualitative, and we are instructed to use sweet as the base category. So I'm going to go to the data. So you can see here's cider. Again, it's qualitative. So we're going to have to do binary encoding. The data analysis tool pack only accepts numbers, it doesn't accept text. So what you do when you have more than 2 groups is you have a base category. So if you look at the data, you can see that we have 3 groups, or 3 categories. It's sweet, semi-dry, and dry. And sweet is the base category. So what you do is you do binary encoding for every category except for the base. So we're going to create a column for every category except for the base. So I'm going to create a column for dry and another column for semi-dry. So everyone except for the base, which is sweet. And now I'm going to do binary encoding. So if the type of cider equals dry, I'm going to code it as a 1, if not a 0. And then binary encoding for semi-dry. So if the type of cider equals semi-dry, then 1, if not 0. And like I said in the previous videos, do not put these numbers, 1 and 0, in quotes because that'll store it as text. All right. So I'm going to do the data analysis tool pack and regression. The y variable is the variable we want to be able to predict, and that's total cost. So we want to be able to predict the total cost, and we are going to use these 3 variables. Again, we're not going to include cider because we can't, because it's text. That's the whole reason why we did the binary encoding, was to convert the text to numbers. And then we have labels. I'm just going to put my output. I'll just put it right here. Okay, the global test. You can see that the global test is significant. It's less than alpha. So that means at least one of the x variables predict y. So again, we're going to reject because alpha is greater than the p-value, or the p-value is less than alpha. So at least one x variable predicts y or cost. So now we're going to go down and do the individual tests to see which ones predict and which, if any, do not. And again, disregard the test for the intercept. We don't do significance testing for the intercept. So the method that we use to remove non-significant variables, I guess first we can go through and say which one's significant and which one's not. So any ones that are less than 5% are significant. So these semi-dry and production volume, these 2 are significant, and then dry is greater than alpha, so that is non-significant. And again, we have to remove all non-significant variables until we get a model or an output that only consists of significant x variables. And we can only remove one variable at a time, so that's the method that we're going to use. Well, here we only have one non-significant variable, and that's dry. So we're going to do the analysis again. We're going to repeat the analysis again, but we're not going to include dry. So the y variable is the same, but now it's just semi-dry. Oops, I did not want to include the y variable. So we're just including semi-dry and production volume, and then I'm going to put the output right here. Global test, again, is significant. At least one x predicts y. We have 2 x variables, and they are both significant. Both of their p-values are less than alpha. So this is the final model. This is the model that we're going to work with. So I'm just going to copy it, and I'm going to paste it over here. All right, so the global test. Again, the alpha is greater than the p-value or the p-value is less than alpha, so we are going to reject. And that means at least one x variable predicts cost. Now we can go to the individual tests. So what is the final conclusion regarding dry? Well, we removed dry. It was non-significant, so it is not predictive of cost or price, so I'm going to say C. What is the conclusion regarding semi-dry? Well, if you recall from the first video, in the first video I went over these notes regarding how to interpret slopes, and semi-dry was qualitative data. So if the slope, we have to look to see if the slope, the sign is positive or negative. And for semi-dry, it is positive. So if the slope is positive, that means whatever group you coded as 1 is associated with higher values on that y variable. So we coded semi-dry as 1. So semi-dry is associated with higher costs or higher price. So that would be A. The correct answer would be A. And then production volume. Production volume was quantitative, and it's pretty easy to interpret quantitative slopes. So if the slope was positive, and it was, there's a positive relationship. So increases in x predicts increases in y. Or in other words, increases in production volume predicts increases in price. So that would be A. All right, now the coefficient table. Just going to reference the values. So these coefficients, this is basically the values in the intercept and then the slope. So, oops, dry was NA. Again, it was non-significant. Anytime you have a non-significant variable, please put NA, and it's in the instructions, so do that for the homework, exams, anything like that. The slope for semi-dry is 175. P-value is right here. Production volume, the slope is 8.24. Here is the p-value. Standard air is right here. And here is our r squared. All right, so for the coefficient table, we're basically just referencing things from the output. Okay, so now we're going to do our prediction table. So first I'm just going to do the binary encoding. And now we can estimate the cost of production. So we are going to use a regression equation. So again, the regression equation is the intercept plus, and then for each significant variable, so we're not going to include dry, it was non-significant. So for each significant variable, so that we'll do semi-dry first, it's the slope, which is right there, times the value. So for the first row, it's 1, and then plus the slope for our second variable. So here's the slope for production volume times the value for production volume. And it is 7,534. So if we have a batch that's semi-dry and the production volume is 800, this is how much we estimate it's going to cost. Now we're going to compute the prediction interval. So that's a range in which we're going to be 95% confident that the actual cost will fall in. And that is y hat. Again, y hat is just estimated or predicted y, so estimated cost plus 2 times our standard error. The lower prediction interval is y hat minus 2 times the standard error. All right, so let's just think about what we just computed. So if we're making a batch of cider that is semi-dry and we're producing 800 units, we estimate that it's going to cost $7,534, and we are 95% confident that it'll actually cost between $7,300 roughly and $7,700. Wow. So again, our estimations, they're not going to be 100% accurate. We know that there's going to be some error associated with it. So a lot of times people like to compute the prediction interval because it's a wider range of estimation, but we're more confident that the actual cost will be within that range. So that is it for the second tab.